Welcome back, everybody. We're going to continue working on R.1 and finish that today. So the next thing we're discussing is complement of a set. Let's say you have a universal set: pork, beef, turkey, fish, chicken. You have set A that only has fish and pork in it. The stuff left over from the universal set that is not included in set A is called the complement of set A, written as A, and that little apostrophe means A prime. So those are the words that you would hear with those, A prime. We have a universal set of, again, beef, pork, turkey, fish, chicken. So if we asked you for the complement, what's in it? And we know that set A has fish and pork, then we would write beef, turkey, and chicken. Those would be the elements of the complement. We have another universal set, 0, 1, 2, 3, 4, 5. Set A is 0, 4. So what belongs in the complement of A then? Well, 1, 2, 3, and 5. Those are the 4 elements that are not included in set A. That would be its complement. And so here is the algebraic way to write what a complement is. X such that X is an element of the universal set, but not an element of set A. Let's try a couple. All right, universal set. We have 1, 2, 3, 4, 5, 6, 7. Set A, 1, 3, 5, 7. Set B is 3, 4, 6. First, it's asking us for A prime. This U goes over here. Sorry about that. So A prime. Let's find all the elements that are in the universal set that are not in set A. So A prime would be 2, 4, and 6. Those are the 3 elements that are not in set A, but part of U. The complement of set B. B has 3, 4, and 6. So I'm going to change this ink here. So 3, 4, and 6. That means we would still have 1, 2, 5, and 7. So 1, 2, 5, and 7 would be in the complement of B. C, the empty set. The empty set prime. So remember, empty set means that we have, let's say, set C that have no elements in it. There's nothing listed. So if there's nothing listed, then what part of this would we cross out? Well, we don't have to cross anything out. Nothing means that the universal set would be the complement of the empty set. Or 1, 2, 3, 4, 5, 6, 7. Last but not least, we have U prime, or the complement of the universal set. If the universal set is everything, then the complement to that would be the empty set, nothing, because we already put everything in our set. So there's nothing left to put that didn't get included. The intersection of two sets. The intersection means elements they share or have the same. Set A, 1, 2, 4, 5, 7. Set B, 2, 4, 5, 7, 9, 11. 2, 4, let's see, I see 7 and 5. They share those. So this is the answer to the intersection. The intersection has the upside down U. All right, the intersection is the upside down U, kind of trying to bridge what's the same on both sides. Set builder notation, the intersection is X such that X is an element of both A and B. If two sets have no elements in common, they are called disjoint sets, and their notation would be the empty set because they don't have anything to write down that's the same. All right, examples. Example A. So what's the same between the two sets? I see 15s, I see 25s, and that's it. So their intersection would be 15 and 25. B, I see a 2. Oops, I don't know why I just circled a 1. That was silly. So 2, 3, and 4 are the same, and that's it. Their intersection set then would just be 2, 3, and 4. Example C, I have 1, 3, 5 intersection with 2, 4, 6. Well, nothing is the same, so I would write either this or the 0 with the line through it to say it's the empty set, there's nothing the same. Union of sets, all elements that are included in either one. So list everything they have. You do not have to write the repeats. You can, but you don't have to, and typically we don't. So when you would see these answers, or if you were on a multiple choice, they would only write them once. So we have a 1, we have 3, which we already wrote there. We have 5, which we already wrote there, 7, and 9. And so those are all of the different numbers that are part of both sets A and B. And union is listed with a U. That makes sense, hopefully. I like when they match. Union U. Set builder notation, A union B, is X such that X is an element of A or B. So it can be either one. It doesn't have to be both. Our last set of examples, the union here of these two sets. So we have a 1, a 2, a 3, a 4, a 5, 8, 9, and 14. You don't necessarily have to write them in order, but it is helpful when we're doing other things with these to make sure that they're in order from least to greatest. There should be no empty sets or disjoint sets here because we're combining sets, so it doesn't matter if they have stuff the same or not. The union for B, we have 1, 2, 3, 4, 5, 6, and 7. And then this last one, we have the odd numbers going on to infinity, the even numbers going on to infinity. So you could write it as 1, 2, 3, 4, 5, 6, 7, and then ... to show that it goes on forever. But the answer that's going to be listed on a multiple choice or in the answer key or something is actually going to be the capital letter N. And if you remember back to the very first page of notes that we took for this at the top of the vocabulary, remember that N stands for natural numbers because it begins at 1 and goes on infinitely. All right, everybody, that's it for today. Have a great night.